Hello again. This lesson is about adding and subtracting radicals. So it's a continuation of the radicals chapter that we've been in for a good month or so now. So you've seen this before in some of the examples that you've been doing the past few days, where you're going to get an expression where you cannot actually add or subtract the problem. So in this case, you will be able to see similar radicals that you are allowed to add or subtract. So the main point for adding and subtracting radicals is the fact that you need like radicands in order to add or subtract. So if you look at this problem right here, you have the square root of 7 and the square root of 7. Those are like radicands. So, and you learned this word when we were back in the classroom. So the radical is the whole thing, and the radicand is the number that's underneath the radical symbol or the square root symbol. So in order for you to do this problem that you see right now, they would both have to be the same number underneath the radical symbol. So think of it like this. Think of when you were in grade school and you learned how to combine like terms. You could only combine like terms when the letters were the same. So if you took 3x and 4x, you would know, okay, well, 3 plus 4 would be 7, and it was just an x. It was not an x squared because you just tacked on the ending. Okay, so you added the coefficients and put x at the end. So if you would look at this problem, you have 3x plus 4x, and these are not like terms, obviously, because they don't have the same letter. So not like terms. So all of this is pretty much similar to radicals. So if you don't have the same radicand, you cannot simplify. So here's the main point of the lesson. Unlike radicands cannot be combined, only ones that are the same can. So just think about it like combine like terms. So for our first example, this is which is the problem you just saw. So if you were to highlight radical 7 and radical 7, obviously they are the same. So there really is no work for this problem. So you would just take 4 plus 5, and it's going to be radical 7. So obviously you get 9 radical 7. This is your answer. Now, again, you didn't have to show me the work of 4 plus 5. That was pretty much mental math. Okay? Now, of course, they're going to get a lot more difficult than this. So let's look at B. So if you look at B, you see a radical 6, a radical 13, and a radical 6. Now, we have a slight problem because they're not all the same. But I do see that you have 2 of them that are the same. So I'm going to go ahead and just erase this one because these 2 are the same. And just this note over here that the order of your answer doesn't matter. Okay, so it won't matter which radical you would put in the front or the end of your answer. So if you look at this problem, you have 3 radical 6 plus 5 radical 6. So we're going to do 3 plus 5 radical 6. Notice that this is a plus 5, and obviously this is a plus 3. So you're going to get 8 radical 6. And, well, this does not have a matching buddy. So I'm just going to swing it down in your answer, and this would be my answer. So like I said, or you could have the other way around and have negative 2 radical 13 plus 8 radical 6. So order does not matter. Okay? And again, for this problem, you would really have to show me no work because it's all mental math. Okay, now we're going to get more difficult. So again, we're trying to find like radicands. So if you have radical 3, radical 6, radical 48, radical 54. Well, none of those are the same. But I do realize that 48 is a pretty large number and 54 is a pretty large number. So perhaps we need to break those down. So I'm going to erase everything because obviously I can't highlight anything because nothing's the same. So there are no like radicans. So you need to see if you can simplify any of the larger ones. And obviously the larger ones being, we're going to simplify this and simplify that because the radical of 3 and the radical of 6 are already down to lowest terms. So I'm going to kind of make this sort of a separate problem. So I'm going to bring this down here. So I got 2 radical 48. So let's break that down. Don't forget, circle your 2 in front. So 48 has, I'm going to go with the square root of 16 and the square root of 3. So this is 4 square root 3. So obviously this answer now is you got 2 times 4 is 8 radical 3. I'm not going to do anything just yet. This one over here, I'll do below. So 6 radical 54. I think that 9 and 6 go in there. So this would be a 3. Don't forget to circle your 6. So this answer would be 18 radical 6. Now, the only thing I did was I changed this one and I changed this one. So I thought I had another space for a slide. So let me actually just add a slide here. I'm not sure if I can do that. Well, we're just going to roll with it anyway. So I'm just going to erase all of this because I'm done with it. I'm going to erase all of this because I'm done with it. And I'm going to rewrite this up here because now that's the new problem. And this is a negative 18 radical 6. So again, I'm just going to get rid of all of this. Okay, so let's get my highlighter and let's highlight the same radicands. Well, I see this one is radical 3. This one's radical 3. And I do believe this would be then 7. Whoops, not sure what that is. Okay, sorry about that. So you have 7, and we have a plus 8. So this is going to end up to be radical 3. So I do believe we get, 15 radical 3. And then if I look at my other radicands, looks like you have, this one and this one. So you have a negative and a negative. So plus, you have negative 4 minus 18 radical 6. So let's clean this up. We have 15 radical 3, which was from before. This is going to give us negative 22 radical 6. Oops, sorry about that. And again, of course, you can switch order if you would like. So the only real work would have been getting these two answers. So, I mean, you don't have to show me work of adding and subtracting, but breaking down the larger radicands is the work that you would have to show me. All right, and I have one more. So let's look at this one. Obviously, you see 0 like radicands because I see radical 2, radical 27, radical 98. So there are no like radicands. Obviously, we're going to have to simplify those large ones. So this one is good. Looks like we need to break up 27 and 98. So I'm going to bring this one down like I did before. Circle my 2. Inside of 27, I do believe is 9 and 3. So for this answer, you're going to get 6 radical 3. I'm just going to put that right above here. It's a plus. And this, do this one, 3 radical 98. This is the one rare problem I told you about where you're going to need to try 49. And I believe you get 7. Circle your 3. Circle radical 2. So you get 21 radical 2. Put that up here. That's a negative 21 radical 2. So erase all this. And now we are allowed to highlight the like radicand. So it looks like we have this one and just this one. So we have what, 25 minus 21 radical 2, which is going to leave us with 4 radical 2. And obviously this, well, it doesn't have another like buddy. So there is my answer. And again, you can certainly switch the order because the order of the answer does not matter. Okay, so pretty much the main point of this was to look for like radicands. And if you don't see any, well, you're going to have to find some somehow. There's no way that I'm going to give you a problem where you're not going to have to do any work. Or, I mean, break things down. And we've been breaking radicals down for a good month now. So go ahead and get on big ideas and do adding and subtracting radicals. And I will see you next time.